Hello everyone. In this video, let's learn about set reset latch, or known as SR latch. So SR latch circuit is a two NOR gates connected in series, and then let's call the output of the second NOR gate Q. So Q will be a feedback fed back into the first NOR gate. And then we have each NOR gate has two inputs. So let's call this is the set input, denoted by S. And then the second input of the second NOR gate, let's call it R, which means reset. So let's assume we start by Q is 0. So what is the next state of the system? So which call a Q plus. So this 0 will be fed back to the first NOR gate. So we'll have here 0. Assume S is 1 and R is 0. So from the first NOR gate, we have 0 and 1. So when those are NOR together, the output of the NOR gate will be 0. And now for the second NOR gate, we are NORing 0 and 0. So 0 and 0 will give us 1. So which will be the next state. So this is what we call sequential circuit, where the output of the system is dependent not only on the input, but on the history of the outputs of the system. So we saw Q plus is dependent on the output from the previous state, which is 0. So now let's jump into the SR latch, which is this circuit here is an SR latch, but let's redraw it. So this will be, we have two NOR gates. The first one, which will output what we call here Q bar, let's call it. And we have the input is S, which we obtain from here. And now let's draw the other NOR gate. And then the output will be Q. One input of the second one will be reset. So Q will be fed back into the first NOR gate, as we saw. And then Q bar will be fed back to as an input to the second NOR gate. So this is the circuit of the SR latch. Now let's draw what we call the state table. The state table shows the behavior of a sequential circuit. It has inputs, current state output, and next state output. So the state table of SR latch. So we have S and R are the inputs, and the output is the next state Q plus. When S is 0 and R is 0, the output will be Q. Or in other words, no change to the output. When S is 0 and R is 1, the output will be 0. When S is 1 and R is 0, the output will always be 1. When S is 1 and R is 1, this is invalid state or not allowed. Now let's prove this table. How did we obtain the next state? So to prove this table, let's list the inputs S and R, the current state denoted by Q, and the next state, which is Q plus. Let's go over the cases we may have. So for the S and R, we have 0, 0, and then a Q could be 0 and could be 1. And then the next case, S is 0 and R is 1. And a Q also could be 0 in this case and could be 1, the initial state. So the next case, S is 1 and R is 0. We'll write it twice because also Q could start at 0 and could start at 1. And lastly, we have S is 1 and R is 1. Also Q could be 0 and could be 1. So let's prove this output here. So let's start by case 1. This is case 1. So when Q is 0, let's start by the first line. And then let's start from our circuit. When Q is 0, and we have, in this case, S is 0 and R is 0. So for the top NOR gate, we'll have 0 and 0. So 0 NORed with 0, the output will be Q bar will be equal to 1. And then now 1 will come here. So for the bottom NOR gate, we'll have 1 NORed with 0. So the output will be 0. So Q plus will be 0. So the first line will have 0. Now let's see when a Q is 1. The current state Q is 1. So 1 will come here. The top NOR gate will have 1 NORed with 0. So the output from the top NOR gate will be equal to 0. And then 0 will come here for the bottom NOR gate. 0 NORed with 0. The output for the next state will be equal to 1. So this is 1 here. And then now we notice that in both cases, so Q plus is equal to Q. Because we see when Q is 0, Q plus is 0. When Q is 1, Q plus is 1. Now let's go over the second case. So this is case 2. S is 0 and R is 1. And then let's start by the first row in case 2, where Q for the current state is 0. So having 0 here, 0 will come here as a second input for the top NOR gate. So 0 NORed with 0, the output here will be 1. And then 1 will come here as another input for the bottom NOR gate. So 1 NORed with 1, the output Q plus will be equal to 0. So this is 0 here. Now let's see when Q is equal to 1 for the current state. So when Q equal to 1, 1 will come here. So we'll have 0 NORed with 1. So Q bar will be equal to 0. And 0 will come here at the bottom. So 0 NORed with 1. So Q plus will be equal to 0 as well. So in this row, we'll have 0 again. So clearly we see that the next state Q plus is equal to 0 independent of the past state. So when Q is 0, the next state will be 0. When Q is 1, the next state also will be 0. So next, let's go over case 3 where S is 1 and R is 0. So S is 1 and R is 0. And let's go over this row first, where the initial state of Q is 0. So when Q is 0, let's see the next state of Q. So 0 will come here. So one node with 0, the output Q bar of the top NOR gate will be equal to 0. And then 0 will come here. So 0 node with 0, the output of the next state of Q, denoted by Q plus, will be equal to 1. So we'll have 1 here. So next, let's see when Q, the current state of Q is 1, so what will be the next state of Q? So when Q is 1, 1 will come here. So one node with 1 for the top NOR gate, so Q bar will be equal to 0. And 0 will come here, so the bottom NOR gate 0 is NOR with 0. The output for the next state will be also equal to 1. So this row will have 1. So that's why in this case, we will always have the output will be set to 1. Here we have 0, here we have 1, and then in the first case we had Q. So let's see the last case, the invalid case. Let's call it case 4, where both S is 1 and R is 1. So S is 1 and R is 1. And let's start by the first subcase where Q is 0. Let's see what happens. So when Q is 0, 0 will come here. One node with 0 for the top NOR gate, so Q bar will be equal to 0. And then 0 will come here. So 0 node with 1 for the bottom NOR gate, the output will be that for the next state, so Q will be 0. This is why this is invalid, because it's not possible to have Q is 0 and Q bar is 0, because a Q bar is the complement of Q. So that's why we say this is invalid or not possible. So I hope this was helpful on the SR Latch. Thanks for watching.
If you enjoyed this video, make sure to subscribe to the Computer Engineering Notebook for more content on computer architecture, embedded systems, and hardware design. Hit that notification bell so you don't miss our next tutorial.